Hello and welcome to Math200 Statistics Online here at Cañada College. My name is Lapuz. In this video, we will take a look at a homework problem from homework 1.8-1. or 8.1-8.2. This is problem number 4. It says to estimate the mean temperature for the following sample temperatures. So we have a sample of temperatures, and they range from 18, you got 5.6, and there's a -10. A 3.19, oh, there's a 53. So this is pretty wildly, it has a large deviation, it looks like. So our standard deviation will be quite large, which means our confidence interval will probably be quite large also. Here they want us to find an 80% confidence interval. And then they want us to express our answer with an open interval, parentheses, accurate up to 3 decimal places. And we're going to assume that the data is obtained from a population that is normally distributed. Okay, nothing about, well, let's make a note of that. There's no population standard deviation. So we will use the t distribution, and in using the t distribution, we're going to go straight to our calculator. Now, if you have this data set plugged into your calculator, we're not going to use calculator, we're going to use Google Sheets. But if you had a calculator, you would enter all this data, and then it turns out that the t interval command has an option of actually going straight into your data, your original data set, and then it will calculate the mean and standard deviation as needed. Because you know, when we do our EBM here, our error bound, it's going to involve the t distribution and t sub alpha over 2, and then we need to multiply it by the standard deviation divided by square root of n. And then after we get that, we add it and subtract it from the mean. And so we need this, the sample statistics x bar, s, and n. And again, in the calculator, if you have this already down, it would compute it automatically for you. Or you can calculate it separately and then put in the statistics. We're going to be using our Google Sheets, and here I have the data already inputted in the Google Sheets and ready to find the mean, the standard deviation, and the sample size. So we'll start with the mean. If you remember the command for finding the mean, it's average, and then I'll just click and drag to encapsulate all the values that we're looking for. We got a mean of 19.1. Standard deviation equals STDEV. And then there's options here. Technically, you're looking for the standard deviation of the sample, but if you just do regular standard deviation, STDEV, that'll find the correct sample standard deviation that we want. And then our sample size is, well, you can count down here and you see 9, but if you want Google Sheets to count it for you, the command is set equals and then count. And then you're going to count these values. So the command will count the number of cells that contain numbers. So if you have any blank cells here, it will not count that. So if that ever happens, then you probably want to use this command. Otherwise, you can just, you know, count how many cells there are here. So we have our values that we need, and then now we got to go back and find our t critical value. And this is an 80%, so this is going to be your t sub, so alpha would be 20%, 0.2, and then half of that is 0.10, so 0.10. That's going to be the how you would call your critical value. And then what do? We say equals t dot inverse, and then we're just going to count this 0.10 as a probability, and the degrees of freedom is 1 minus 9, or 9 minus 1, which is going to be 8. Now remember, I'm choosing to find a critical value on the left side of your t-distribution, and this also goes for the normal distribution, and I'm getting a negative number, but of course we want a positive number, so I'm going to scoot my cursor in here right after the equal sign and throw a negative sign there to say I want the negative of that negative number, which makes it a positive, and I want that to be a positive number. Now our EBM is going to be equals to, if you remember, it's going to be the t critical value, and then times, and then that's going to be the standard deviation divided by the square root, SQRT, of the sample size, which is going to be 9, close the parentheses for the square root, close the parentheses for the other expression. So we have a rather large error bound for the mean here of 13. And like I said, our standard deviation was large to begin with because we range from values from negative 11.2 to a high of 69.8. And we only have 9 numbers, so this is really spread out. This data is really spread out. Okay, now we want to find the lower limit and upper limit. So the lower limit and upper limit, and then that's just taking your mean and then adding and subtracting the error bound. So for that, I'll say equals, and then I'll click on the mean, and then the minus the error bound, enter. And then I'm not trusting the autofill here, so I'm going to do it myself. I'll say equals the mean, and then plus the error bound, which gives us 32. So this is going to go from 6.086 to 32.1138, so 114. And then that would serve as our confidence interval. So confidence interval, open interval, so open parentheses 6.086, comma, and then 32.118 or 1138, so that's 114. Okay, and that is going to be our value or our confidence interval. All right, good luck.